Most buyers think they can trust any truck with a good reputation. But what if I told you that most trucks on the market today are engineered to fail after just 150,000 miles? Vehicles that look bulletproof at the dealership, but quickly turn into money pits the second your warranty expires. In this video, we've got the 15 toughest trucks that are literally engineered to outlive their owners, ranked from bottom to top based on real-world reliability data and engineering analysis. And trust me, some of these choices will shock you. From frames that rust through in just 5 years to transmissions that self-destruct at 100,000 miles, most modern trucks are riddled with fatal flaws that'll destroy your investment. And here's the kicker. The #1 truck on this list has a nearly 50% chance of exceeding 250,000 miles, with many examples pushing past 500,000 miles with basic maintenance. Stick with me to the end because this isn't just a ranking, it's a buyer's guide to trucks that won't bankrupt you. Miss this, and you could be stuck with a beautiful truck that costs more to maintain than it's actually worth. Number 15, Ford Courier, 1972 to 1982. The Ford Courier kicks off our countdown as the ultimate example of mechanical simplicity equals longevity. Built by Mazda for Ford, these mini trucks were the definition of basic transportation. What makes these trucks immortal isn't fancy technology, it's the complete lack of it. With extremely simple 1.8-liter and 2.0-liter inline-4 engines, there's literally almost nothing to break. No computers, no sensors, no complicated emission systems, just an engine that burns fuel and makes power. These small workhorses were built before planned obsolescence became standard practice in the automotive industry. They weren't designed to be replaced every few years. They were built to work. The beauty of the Courier lies in its accessibility. Even owners with limited mechanical knowledge can maintain and repair these trucks using basic hand tools. Every component is visible and accessible. No need to remove half the engine bay to reach a simple sensor or pump. Number 14, Chevrolet S10, 1982 to 1993, first generation. The first generation Chevy S10 represents the golden age of American mini trucks, an era when simplicity and serviceability were still prioritized over features and complexity. These compact trucks featured highly basic, reliable powertrains like the bulletproof 2.5-liter Iron Duke 4-cylinder and the serviceable 2.8-liter V6. What made these engines special wasn't cutting-edge technology. It was conservative engineering that prioritized reliability over flashy specs. The Iron Duke in particular earned its nickname through extraordinary durability. With a cast iron block and head, this engine was essentially overbuilt for the lightweight S10 platform. Running at a relatively low compression ratio and modest power output, the engine rarely operated under stress, allowing it to soldier on for hundreds of thousands of miles with basic maintenance. Access to components remained straightforward, with ample space in the engine bay for servicing. Parts availability continues to be excellent, with aftermarket support ensuring these trucks remain serviceable decades after production ended. Even more impressive, replacement components remain affordable, a stark contrast to modern vehicles, where a single electronic module can cost more than an entire engine rebuild on these classic trucks. Number 13, Dodge D150, 1981 to 1993. The Dodge D150 represents what many consider the last era of truly analog truck durability. These workhorses came before the complicated electronics and emission systems that plague modern vehicles. Equipped with robust engines like the 3.9-liter V6 or the legendary 5.2-liter VE8, these trucks delivered reliable performance through simple, proven designs. Their longevity is secured not by advanced technology, but by the relative ease of maintenance and diagnosis. The 5.2-liter V8, 318 cubic inches, deserves special attention for its extraordinary durability. This engine features a deep skirt block design that provides exceptional rigidity, minimizing vibration, and wear over hundreds of thousands of miles. The hydraulic lifters eliminate the need for periodic valve adjustments, while the cast iron construction provides thermal stability that modern aluminum engines struggle to match. Fuel delivery on early models came via a simple, reliable Carter BBD carburetor that could be rebuilt in an afternoon. Later fuel-injected versions used a straightforward throttle body injection system that avoided the complexity of modern multi-port setups while still delivering improved efficiency and cold start reliability. Number 12, Nissan Frontier, 2005 to 2021, second gen. The second-generation Nissan Frontier earns its place on this list by doing something few modern vehicles achieve: staying in production for 16 years with minimal changes. This unprecedented production run speaks volumes about the reliability of its core design. With a 12.5% chance of reaching the quarter-million-mile mark, the Frontier delivers durability through what experts call no-frills engineering. At the heart of this truck is the VQ40DE 4.0-liter V6 engine, a power plant that prioritizes reliability over cutting-edge performance. This engine features a timing chain rather than a belt, eliminating a major maintenance item that plagues many competitors. The chain is designed to last the lifetime of the engine, often reaching 300,000 miles without requiring replacement. The block and heads are constructed from aluminum to reduce weight, but with sufficient strength to maintain durability under stress. The cooling system is generously sized, with a large radiator that prevents the overheating issues common in many modern trucks, pushed to their thermal limits in the name of efficiency. This conservative approach to cooling extends component life significantly, particularly in hot climates or under towing conditions. Number 11, Ford Ranger, 2006 to 2011, third gen US. The third-generation Ford Ranger has earned a reputation as one of the most durable mid-sized trucks ever produced, with a 14.1% statistical chance of surpassing 250,000 miles. Impressive for its weight class. What makes the Ranger special isn't cutting-edge technology or massive power, it's the opposite. These trucks benefit from smaller size and mechanical simplicity that reduces stress on components and simplifies repairs when needed. The Ranger's engines, particularly the 2.3-liter inline-4 and the 4.0-liter V6, are straightforward, under-stress designs that rarely push their own mechanical limits. By operating well within their engineering parameters, these engines avoid the stress-related failures common in higher-output competitors. The 2.3-liter Duratec engine deserves special attention for its remarkable durability. With a cast-iron block and aluminum head, this engine combines strength with efficient cooling. The timing chain eliminates the maintenance requirements of belt-driven competitors, while the port fuel injection system avoids the carbon buildup issues that plague direct injection engines. The 4.0-liter V6, while thirstier, offers exceptional reliability through simple design. It uses an overhead valve, OHV design with push rods, rather than the more complex overhead cam arrangements found in many competitors. This simplicity translates directly to longevity. Fewer moving parts mean fewer potential failure points. Number 10, Ram 1500, 2009 to 2018, fourth gen. The fourth-generation Ram 1500 stands out as a volume production truck that delivers surprising longevity with a 14.1% chance of exceeding 250,000 miles. Impressive for a mainstream half-ton pickup. While not as overbuilt as heavy-duty models, this generation benefits from robust frame design and the popular 5.7-liter Hemi V8, an engine that balances power with proven reliability. Engineers gave this platform significant structural strength to handle the Hemi's output, creating a solid foundation for long-term durability. The Hemi V8 deserves special attention for its durability. Despite producing substantial power, up to 395 horsepower, the engine achieves longevity through several key design features. The deep skirt block provides exceptional rigidity, while the pushrod design eliminates the complexity of overhead cams. The hemispherical combustion chambers that give the engine its name provide efficient combustion and excellent thermal management. One potential weakness is the multiple displacement system, MDS, which deactivates cylinders under light load to improve fuel economy. While this system can cause issues if oil changes are neglected, proper maintenance with quality synthetic oil minimizes problems. Some high-mileage owners choose to disable this system through tuning, trading slight fuel economy for enhanced durability. Number 9. Chevrolet Silverado 1500, 1999 to 2006, GMT 800. The GMT 800 platform Silverado has become legendary among truck enthusiasts for its durability, with approximately 20 to 25% of these trucks exceeding the 250,000-mile mark, an impressive achievement for a light-duty pickup. At the heart of this truck's longevity is the 5.3-liter Vortec V8 LM7, a power plant now considered one of the most reliable V8 engines ever mass-produced. What makes this engine special is its robust design combined with relatively simple technology before the era of complicated fuel-saving features. The LM7 features a deep skirt block design that provides exceptional rigidity, minimizing vibration and wear over hundreds of thousands of miles. The bottom end is notably overbuilt, with strong connecting rods and a durable crankshaft that can withstand significant abuse. The cylinder heads flow well while maintaining strength, avoiding the cracking issues that plague some competitors. This generation predates General Motors' problematic active fuel management cylinder deactivation system, eliminating one of the most common failure points in later models. The simpler engine management system means fewer sensors to fail and fewer complex systems to malfunction. The GMT 800 Silverado benefited from conservative engineering throughout its platform. The frames were overbuilt, the cooling systems were generous, and the transmissions, while not perfect, were straightforward to maintain and repair when necessary. Number 8. GMC Sierra 1500, 2007 to 2013, GMT 900. The GMT 900 generation Sierra earns its place with an 18.3% chance of exceeding 250,000 miles. Solid performance for a light-duty truck that balances capability with daily drivability. Power comes from the versatile 5.3-liter Vortec V8, part of General Motors' legendary LS engine family. These engines are renowned for their robust bottom end, efficient combustion, and exceptional durability when properly maintained. The LS-based Vortec engines feature a deep skirt block design that provides excellent rigidity and strength. The cylinder heads are designed for excellent flow characteristics while maintaining durability under sustained high temperatures. The valve train, with its simple push rod design, eliminates the complexity of overhead cam arrangements found in many competitors. The cooling system is generously sized, with a substantial radiator and efficient water pump that prevent the overheating issues common in many modern trucks. This conservative approach to cooling extends component life significantly, particularly in hot climates or under towing conditions. Wait, I hope you're enjoying this countdown of trucks engineered to outlast their owners. If you are, hit that subscribe button right now and make sure to turn on notifications so you never miss another video like this one. I release new automotive content every week that could save you thousands on your next vehicle purchase. Now let's continue with number 7. Number 7. Ford F-150, 2009 to 2014, 12th gen. The 12th generation F-150 earns its reputation for longevity with a 19.2% chance of exceeding 250,000 miles, placing it among the most durable half-ton trucks ever produced. What makes this generation special is the robust 5.0-liter Coyote V8 engine. While Ford offers several engine options, the naturally aspirated 5.0-liter stands as the reliability champion. This engine features a strong bottom end, efficient cooling, and relatively simple technology that promotes long-term durability. The Coyote V8 utilizes a deep skirt block design that provides exceptional rigidity, minimizing vibration, and wear over hundreds of thousands of miles. Despite being an overhead cam design, which typically introduces additional complexity, the engineering is sound with a focus on long-term reliability. The timing system uses a durable chain rather than a belt, eliminating a major maintenance item that plagues many competitors. The chain is designed to last the lifetime of the engine, often reaching 300,000 miles without requiring replacement. The variable valve timing system, while adding complexity, is well-engineered and rarely causes issues when oil changes are performed regularly. Consumer reliability ratings for this generation consistently hover around 4.6 out of 5 stars, with an impressive 88% of owners recommending the vehicle. These aren't just marketing claims. They represent real-world experiences of owners who've pushed these trucks to extreme mileage. Number 6. Ram 3500 HD, 1994 to 2002, second generation. The second generation Ram 3500 Heavy Duty stands as a monument to diesel durability, with a 24.3% chance of exceeding 250,000 miles, though many examples push far beyond that benchmark. At the heart of this truck's legendary status is the 5.9-liter Cummins inline-six diesel engine, a power plant that many consider among the most durable motors ever installed in a consumer vehicle. Its inline configuration provides inherent balance and strength, while the robust cast-iron construction delivers exceptional structural integrity. The 12-valve version, pre-1998, deserves special attention for its extraordinary simplicity and durability. This engine uses a Bosch P7100 mechanical injection pump that operates without electronic control, eliminating a major failure point found in modern diesels. The straightforward mechanical fuel delivery system can operate reliably for hundreds of thousands of miles with minimal maintenance. The later 24-valve engines, 1998 to 2002, introduced electronic control, but maintained the core mechanical strength that made these engines legendary. The VP44 injection pump used in these models can be problematic if fuel system maintenance is neglected, but with proper care, these engines routinely exceed 400,000 miles without major internal work. What makes these engines truly special is their relative simplicity. The early 12-valve models, pre-1998, and early 24-valve variants with the P7100 pump offer straightforward mechanical operation with minimal electronic complexity. This simplicity translates directly to longevity. Fewer systems mean fewer potential failure points. These engines are so overbuilt that Cummins maintains a million-mile club, recognizing owners who've pushed beyond the 7-figure mileage mark, a testament to the engine's industrial-grade durability. Number 5. Ram 2500 HD, 1994 to 2002, second generation. The second-generation Ram 2500 Heavy Duty secures its place with a 26.3% chance of exceeding 250,000 miles, though that statistic dramatically understates the potential longevity of these machines. Like its 3500 sibling, the 2500 benefits from the legendary 5.9-liter Cummins inline-six diesel, an engine so durable that it transcends typical automotive lifespan expectations. This power plant delivers massive torque, up to 610 pound-feet in later models, while maintaining exceptional reliability through straightforward engineering. The inline-six configuration contributes significantly to this engine's durability. Unlike V engines with complex cylinder bank arrangements, the straight design provides inherent balance that reduces vibration and associated wear. The cast-iron block and head provide exceptional thermal stability and strength, allowing the engine to withstand the extreme pressures and temperatures of diesel combustion for hundreds of thousands of miles. These engines were designed for sustained commercial operation, which means they're dramatically overbuilt for typical consumer use. When a private owner subjects these engines to intermittent towing rather than constant heavy loads, the components operate well within their design parameters, further enhancing longevity. Number 4. Toyota Tacoma, 2005 to 2015, second gen. The second-generation Toyota Tacoma achieves an astonishing 41.7% chance of exceeding 250,000 miles, making it the undisputed reliability champion of the midsize truck segment. At the heart of this truck's legendary durability is the 4.0-liter V6 1GRFE engine, a power plant engineered with Toyota's signature conservative approach. Rather than pushing boundaries with cutting-edge technology, Toyota focused on proven solutions executed with precision manufacturing. The 4.0-liter V6 features an aluminum block with cast iron cylinder liners, providing excellent heat dissipation while maintaining cylinder wall integrity. The timing chain eliminates the maintenance requirements of belt-driven competitors, while the port fuel injection system avoids the carbon buildup issues that plague direct injection engines. The variable valve timing system, VVTI, adds a layer of complexity but is engineered with Toyota's characteristic conservatism. Unlike systems from some manufacturers that push the technology to its limits, Toyota's implementation emphasizes reliability over maximum performance, resulting in a system that rarely causes issues even at extreme mileage. The cooling system is generously sized, with a substantial radiator and efficient water pump that prevent the overheating issues common in many modern trucks. This conservative approach to cooling extends component life significantly, particularly in hot climates or under towing conditions. The results speak for themselves. Owners routinely report reaching 200,000, 300,000, or even 400,000 miles with minimal major mechanical interventions. This exceptional durability translates directly to market value. High-mileage Tacomas command prices that would be unthinkable for most competitors with similar age and use. Number 3. Ford F-250 Super Duty, 2008 to 2010, second generation. The second-generation Ford F-250 Super Duty earns its bronze medal with an impressive 43.6% chance of exceeding 250,000 miles, placing it firmly among the elite vehicles engineered for extreme longevity. What separates this platform from typical consumer trucks is its commercial-grade engineering foundation. Ford designed these trucks for sustained commercial operation, meaning the core components, frame, suspension, cooling, and drivetrain, feature significant over-engineering compared to light-duty alternatives. While the 6.4-liter power-stroke diesel option gets attention for its power, the true longevity champions in this generation are often the 6.8-liter V10 and 5.4-liter V8 gasoline engines. These power plants lack the complexity of modern diesel emission systems, delivering straightforward operation with fewer potential failure points. The 6.8-liter V10 deserves special attention for its exceptional durability. This engine is essentially a 5.4-liter V8 with 2 additional cylinders, creating a power plant with massive displacement and conservative output. The result is an engine that rarely works hard in normal operation, extending component life dramatically. The deep skirt block provides exceptional rigidity, while the pushrod design eliminates the complexity of overhead cams. Number 2. Toyota Tundra, 2007 to 2021, second gen. The second-generation Toyota Tundra achieves near-mythical status with a 47.9% chance of exceeding 250,000 miles, placing it statistically on par with the heaviest-duty diesel trucks, despite being a gasoline-powered full-size platform. At the core of this extraordinary durability is the 5.7-liter I-Force V8 engine, a power plant that perfectly embodies Toyota's engineering philosophy of conservative design executed with precision manufacturing. Rather than chasing headline-grabbing power figures, Toyota built an engine with generous tolerances, robust materials, and simplified systems that promote long-term reliability. The 5.7-liter features an aluminum block with cast iron cylinder liners, providing excellent heat dissipation while maintaining cylinder wall integrity. The timing chain eliminates the maintenance requirements of belt-driven competitors, while the port fuel injection system avoids the carbon buildup issues that plague direct injection engines. The variable valve timing system adds a layer of complexity but is engineered with Toyota's characteristic conservatism. Unlike systems from some manufacturers that push the technology to its limits, Toyota's implementation emphasizes reliability over maximum performance, resulting in a system that rarely causes issues even at extreme mileage. This philosophy extends throughout the vehicle. The transmission, transfer case, differentials, and even electrical systems were all designed with significant margins of safety. The result is a truck that operates comfortably within its engineering parameters, even when pushed hard. Number 1. Ford F-350 Super Duty, 1999 to 2003 first generation. The first generation Ford F-350 Super Duty stands alone at the summit of truck durability with an unmatched 49.1% statistical probability of exceeding 250,000 miles. Though many examples push far beyond that benchmark, with 500,000-plus mile examples being relatively common. What elevates this platform to legendary status is the 7.3-liter Power-stroke diesel engine, widely regarded as one of the most durable power plants ever installed in a consumer vehicle. This engine features a heavy-duty cast-iron block and heads, conservative power ratings, and most importantly, a mechanical simplicity that's been lost in modern diesels. Designed by international harvester Navistar, the 7.3-liter Power-stroke was engineered from the ground up for commercial applications. The engine block features thick cylinder walls, 7 main bearings for exceptional crankshaft support, and a forged steel crankshaft that can withstand forces far beyond those generated by the factory power rating. The fuel system uses hydraulic electronic unit injectors, HEUI, that combine the precision of electronic control with the reliability of hydraulic actuation. Unlike common rail systems found in modern diesels, this design is less susceptible to catastrophic failure from contamination or pressure spikes. Unlike contemporary diesel engines crippled by complex emission systems, the 7.3-liter Power-stroke relies on straightforward mechanical operation with minimal electronic intervention. This drastically reduces potential failure points and allows for easier diagnosis and repair when issues do arise. If you thought these unkillable trucks were impressive, you need to see my video on 13 popular trucks that got way worse after 2020. These manufacturers quietly downgraded critical components while raising prices. Watch it now to avoid the biggest reliability traps in modern trucks.